Hi guys, this is January 2023, paper 2HR. So first question, show that this divided by this equals this, right guys? Definitely, first thing to do is turn our mixed numbers into improper fractions. And to do that, we do 3 times 4 is 12, plus 2 is 14. So that's 14 over 3, that's 14 thirds. Divided by 6 times 1 is 6, plus 5 is 11, 11 over 6. Okay. And then ignore this, guys. That's the answer. We're not going to use that. Then we're going to do what I like to call keep, change, flip. So we keep the first one, change to multiply, and we flip the second one into 6 over 11. And then you can say, I can divide, you could multiply these out if you want to, guys, but look, this is a nice thing to do. You can divide this by 3, 3 into 3 goes once, and divide this by 3, 3 into 3 goes twice. So this is the same as 14 over 1 times 2 over 11. 14 times 2 is 28. 1 times 11 is 11. So we do tops times the top, bottom times the bottom. And 11 goes into 28 2 times. 2 times 11 is 22. And what's the remainder? 6, which is our 6/11ths, which is what we have here. Okay, that's question 1. Question 2. On the grid, rotate triangle A 180 degrees about 1 minus 1. So this is going to be my center. Now, guys, essentially, what you want to do here is get some tracing paper. So you want to get tracing paper, big sheet of tracing paper like this. Make sure it's big enough, guys, over the full thing. Then you draw this shape on the tracing paper, exactly as you see it. Sorry, not that shape, this shape. You draw it like that. And then you put your pen in here and you rotate the paper. Now you rotate the paper 180 degrees. Now guys, I am not going to be able to do that, but you essentially turn this thing 180 degrees like this. It'll go down here. I sometimes like to even put an arrow on the top here, so when you rotate it, the arrow is facing down. Now, what's important, guys, you rotate it but by putting the pencil in here, like that. And when you do it, you should get an answer like this. So we'll have this guy will be here. This guy will be here, this guy will be here, and this guy will be here. So that will be rotated 180 degrees, about 1 minus 1, about this point. Okay. Then it says on the grid, translate triangle A, that's this triangle again, by the vector -7, 3, and label the new triangle. So sorry, I should have labeled this B, and this one -7, 3, and I'll label it C. So -7, 3 means I go left 7. That will be, let's look at this corner here. 1, 2, 3, 4, 5, 6, 7 here. So this is my new corner there, and I'm going to go up 3. So left 7 and up 3. 1, 2, 3. 1, 2, 3. So now this is this new top corner, and I can essentially just draw the shape now because it looks, if it's a translation, it's the exact same shape. You could do the same with these corners too. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, and this corner 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, and we get this, and this is triangle C. Okay, question 3. Y is an integer, and sorry, 2y is between -8 and 2. Find all the possible values of y. Now be careful, guys, it's bigger than 8 and less than or equal to 2. So firstly, what I'm going to do, guys, is divide by 2. So if 2y is bigger than 8, then y, or negative 8, then y is bigger than negative 4. And if 2y is less than or equal to 2, then y is less than or equal to 1, because I divide by 2 and divide by 2. Now list the integers. Well, it has to be bigger than minus 4, so the first one will be minus 3. It can be minus 2, minus 1. 0 is an integer, guys. It counts as an integer. And it can be 1 because it's less than or equal to 1, so we're going to count 1. Here, write down the inequality. So it's minus 1, but it's greater than minus 1. And because this circle is not colored in, it's not equal to minus 1. So it's x is greater than negative 1. Okay, question 4. Using ruler and compasses only, construct the bisector of angle BAC. Right, guys, I don't have a ruler or a set of compasses, but I'll show you what to do. So put your pointy bit in there. And when you put your pointy bit there, draw a circle basically that crosses this and this. So it has to cross both of them. Now you can draw the full circle, but it doesn't matter as long as it just crosses here and crosses here. Then you put your pointy bit here and here. Now you draw another circle. You may as well keep the same size, although you don't have to, guys. You can make it bigger. What's important is that you keep the same size between here and then when you move it here. Then you're going to draw another arc somewhere over here. Again, doesn't really matter, but it's some kind of arc of a circle there with that center. And then you're going to do the same. This is the point where you definitely have to keep the same size. You do another arc with this circle, something like this. And then you join this to there where they meet, and then you get this perfect constructed angle bisector. Okay, question 5. On the grid, draw the graphs of the graph of 5x plus 2y equals 10. Okay, I'll show you guys 2 ways to do this. One way, probably the preferred way for most students, would be to rearrange this. So we can rearrange this into 2y equals 10 minus 5x. We subtract the 5x from both sides, and then I divide by 2. Y equals 10 minus 5x over 2. And then we get out our calculator, and we can say, let's go to table. If you go to the table, now here we write the function, this 10 minus 5x over 2. And you say g of x, just leave it blank. And then the start is minus 2, and the end is 4. Step 1 is fine. And then you get a table of values. And the table of values is for minus 2, minus 1, 0, 1. You can even write these table of values here, guys. You can do x and y like this. And then you just do from minus 2, minus 1, 0, 1, 2, 3, 4. And in the calculator it was 10, 7.5, 5, 2.5, 10, 7.5, 5, 2.5, and let's continue down. 0 minus 2.5 minus 5. 0 minus 2.5 minus 5. And this is like here, 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 here. Okay, and then you just fill in these values. So minus 210 is here. Minus 1, 7.5 is somewhere here. 0, 5 is here. 1, 2.5 is here. 2, 0 is here. 3 minus 2.5 is here. And 4 minus 5 is there. Now make sure, guys, you do stop at that point. You don't go any further. Okay, guys, I'll just have to continue this here. Okay, like that. And then you stop. Now, as I say, guys, probably my preferred method is that this is the quick way to do it. You do similar kind of thing, a table of values, but you only need 2 points to draw a line. Because think about it, if I just had 2 points, I just join the 2 points and continue the line. So I like to actually do when x is 0 and I sub 0 in here, which means that disappears, 2y equals 10, which means y is 5. So when x is 0, y is 5, and when y is 0, x is 5x equals 10, x is equal to 2. So now I just put in my 2 points, 0, 5, and 2, 0, which I have, 0, 5, and 2, 0. And then I just join these 2 points. But because he wants it all the way to 4 and negative 2, I go to 4 and I continue it to negative 2, which is here. Both perfectly correct and both full marks. Okay. Question 6. In a bag, there are only red counters, blue counters, green counters, and yellow counters. The total number of counters is 80. Then it gives you this many red, this many blue, this many green in terms of x. And he says, Jude takes a random counter from the bag. The probability it is red is a quarter. Okay, so let's start with that. So that means x plus 7, because there's x plus 7 red, out of 80, because there's 80 in total. This out of this must equal 1 out of 4. Okay, now let's multiply across by 80. X plus 7 equals a quarter times 80, or 80 over 4. Do that with your calculator, guys. It's 20. And therefore, x is equal to 13. Now, if we have x is equal to 13, then we can find the probability that Jude takes a yellow counter. The probability it's yellow is equal to... okay, sorry guys, I don't have yellow, but we can figure this out. X plus 7 plus, let's not do x plus 7. Let's say in red, there is 13 plus 7, which is 20. Blue, there is 13 minus 11, which is 2. And green, there is 3 times x, which is 39. Okay, now, if we have this many for red, blue, and green, then what's left is what's going to be yellow. So that's 41, 51, 61. There's 19 left to give me a total of 80. And now I can just do probability of yellow is equal to 19, because it's 19 yellow, over 80. And that is it. Question 7. Find the highest common factor, HCF, of 200 and 420. Right, 2 marks, guys, which means we can go straight to 200 equals and 420 equals. And I'm going to use my calculator here, show you a little trick if you don't know it already, guys. We can do 200 equals like this, and then if we do shift here and we get this fact, it gives us the factors. So it's 2 cubed times 5 squared. So this is 2 cubed times 5 squared. And the same with 420. So 420 equals shift fact 2 squared times 3 times 5 times 7. 2 squared times 3 times 5 times 7. Is that what I said? 2 squared times 3 times 5 times 7. Okay, good. Now what's common in both of these guys? So the highest common factor is equal to, so there's a 2 squared here and there's a 2 squared here. And I know there's a 2 cubed, but it's only the 2 squared that's common. And there's a 5 here and a 5 squared here, so there's a 5 that's common. So it's just 2 squared times 5, which is 4 times 5, which is 20. So the highest common factor is 20. Okay, next one. A, B, and C are these. Find the lowest common multiple, LCM of A, B, and C. Write your answer as a product of prime factors. Okay, so guys, I am going to draw a Venn diagram because this one's a bit more complicated. Okay, so this is my A, this is my B, and this is my C. Okay, not bad. That's right. Let's write it though. This is A, this is B, and this is C. Now I'm looking for what's common. So what's in all of them? Well, this is 2, 3, 5, 7, this is 2, 3, 7, and this is 3, 5, 11. So the only thing that's common in all is the 3. Let's use a different color. So 3 goes here. Then what's common to A and B? Well, we have a 2, and A and B, we have a 2, and we have a 7, and we have the 3 that's already here. What's common to A and C? We have the 3 that's already there, and we have a 5. And what's common to B and C? Just the 3 and nothing else. Okay, now what's left for A? Well, we have 2 squared, because there's 3 2's all together, and I have 2 here and 1 here. The 3 is here. The 5 is here. I have a 7 there, but I need another 7 because it's 7 squared. B, the 7's there, the 3 is there. I need another 3 because it's 3 squared, and the 2 is there. And then C, we have a 3, a 5. I need another 5, and I need an 11. Okay, so the LCM is just all of these multiplied together. So it's 2, and you can act, because he wants it in the product of prime factors, I can just start, I'll start with the 2's. I do 2 cubed, because there's 2 squared times 2, times 3 squared, I have 2 3's, times 5 squared, I have 2 5's, times 7 squared, I have 2 7's, and then finally times 11, because I have 1 11, and that's it. That's the answer. Question 8. 60 students at a mathematics exam. Sat a mathematics exam. The mean mark for 32 in class A was this. The mean mark for 28 students in class B was this. Find the mean mark for all 60 students. Okay, this is a standard, straightforward, not easy, but it's a standard combined mean question. So what we do is we say, right, 32 students, mean was 55. So we say, okay, let's just assume they all got 55. That's the total for class A. Class A total. And then we do the same for class B. 28 times 52. That's the total for class B. You don't need the brackets there, guys, but it looks better, and you're less likely to make a mistake. So this is the grand total, and all divided by 60, because there's 60 students in total. So we're going to divide the grand total by the total number of students, and this is going to give us the answer. So it's 32 times 55 plus 28 times 52 all over 60, and we get 2685, which is 53.6. 53.6, I can write it here, 53.6. Question 9. Teresa invests 2,000 for 3 years, 4% compound interest. How much will she have after 3 years? Okay, another fairly standard question, guys. We have 2,000, invest at 4%, so we multiply by 4.04. That increases it by 4. And then we raise it to the power of 3, because we're going to do it for 3 years, or 3 times. So we're multiplying by 1.04 times 1.04 times 1.04, and this gives us 2,000 times 1.04. 1.04 to the power of 3, which is 2249.7 to the nearest dollar. Let's just write 2249.73 to the nearest dollar is 2250, because I round up to 50. Okay, Sam invested $T. The investment decreased by 9%. At the end of the first year, it was this. Work out the value of T. Okay, so first thing, guys, I'm going to do 100 minus 9, which is 89. So this is the percentage. Sorry, that's wrong. It's 91. So it is decreased by 9%, but I need to find 91% of it to find out what its new value is. Now, it was T, so I don't know what T is. And I multiply it by 0.91, because the thing he invested times 0.91 gets 91% of the thing he invested, and we are told that this is 1365. And all of this together, guys, means that t is 1365 divided by 0.91. So let's just write that out. 1365 divided by 0.91, and we get 1500. 15, this is t equals $1,500. 1,500. Question 10. The diagram shows two solids A and B. Okay, we're given solid A and solid B's mass, and this is a cylinder. It says all of solid A is melted down to make, and B is melted down to make solid C. There's no change in mass. Work out the density of solid C. Give your answer correct to one decimal place. Okay, so guys, density, let's start with this. Density is equal to mass over volume. It's the mass per volume. So we need to get the total mass and the total volume. Now the total mass is easy because we have mass A plus mass B, and we're given mass A, it's 2000, we're given mass B, it's this, so it's 5,375 grams. That is the mass, the total mass. The volume now, we have the volume of this, but we need the volume of A, so let's do volume of shape A. Now this is a cylinder. We know, guys, the volume of a cylinder is pi r squared h, which is pi times 3 squared times 7, which is, you can actually just leave this in terms of pi, guys. That's 9. 3 squared is 9 times 7 is 63, so it's 63 pi. So the density of C is equal to the total mass, which is 5,375, over the total volume. And the total volume, guys, is the volume of A, which is 63 pi, plus the volume of B, which is 450, which it gives us that. And then we can just do this in the calculator, and we get 5,375. Use this, guys, 63 pi is here, 63 pi plus 450 equals 8.29577. He wants it to one decimal place, so it's just 8.3. So I'll do approximately equal to 8.3. And down here, guys, it gives you the unit. It's grams per centimeter cube, which is our mass per volume. Remember, if you ever forget the formula for mass, guys, look at the units at the bottom, and that might give you a hint. It's mass per volume, or mass over volume. Okay, question 11. We have 5 sides of a regular polygon. Okay, so guys, that is AB, BC, CD, E, DE, and EF. So this is a regular polygon. Fine. These are straight lines. RST is parallel. Fine. Angle RSC is 128. This is 128. UCV is 32. Fine. And work out how many sides the polygon has. Show clear working. Okay, so how many sides it has. The key, guys, to find out how many sides a polygon has is to get the external angle. And by the external angle, I mean this one. The external angle, if I continue that on here, this is the external angle. It is the same angle as this one, or this one. So whichever one you want. If I get that, I can do 360 degrees divided by that angle, and that will give me my answer. Now also, guys, it is this one which is key, right? So BCV is a straight line, so it's also this angle here. So the key, guys, to this question, I believe, is to find this angle. Let's call it X. This is angle X. Okay, now look, these are parallel, which means this angle and this angle are the same because these are alternate angles, or like Z angles, if you like. So this is 128 and this is 128. If this is 128 and this is 32 and this is a straight line, they need to add up to equal 180. So 128 plus 32 plus X equals 180. Some quick maths here, guys. This is 160. X has to equal 20 degrees. So if X is 20, I just then go 360 divided by 20 is 18. Therefore, the polygon has 18 sides. So this is 18. Okay, question 12. Simplify. This is easy, guys. Anything to the power of 0 is 1. 2 over 1 is 2. Next one. 16 to the power of 3/4. You can do this on the calculator, guys, but it's the 4th root of 16, which is 2. 2 cubed is 8. So that's 8. And then a to the 4 to the power of 3/4. You have to do them both separately. You just multiply the powers. So that's just a cubed. So we're left with a final answer of 8a cubed. Then expand and simplify this. Two ways to do it, guys. You can do this first and multiply by 5x, or multiply the 5x first. I think I'll do the 5x first. So 5x times 3x plus 4. This is equal to 15x squared, this times this, plus 20x. And then I multiply this by 2x minus 1. So it's 15x squared plus 20x times 2x minus 1. 15x squared times 2x is 30x cubed minus 15x squared plus 40x minus, plus 40x squared minus 20x, which gives us 30x cubed plus 25x squared, when I add these two, minus 20x. Okay. Question 13. A rectangle has length L and width W. L is increased by 20%. W is decreased by 35%. Calculate the percentage reduction in the area of the rectangle. Okay, that is a good question, guys. So, the normal area is equal to L times W. This is area, let's just call it area 1. This is before the increase. Now L is increased by 20%. So let's say new L is equal to L times 1.2, because if we're going to increase it, we're going to multiply by 1.2 to increase it by 20%. So it's 1.2 L. And the new W, we're going to decrease it by 35%. So it's 0.65 W. That's how to decrease something by 35%, get 65% of it. Therefore, new area, new A, is equal to 1.2 L times 0.65 W, which is the same as 1.2 times 0.65. Let's do that. 1.2 times 0.65, which is 39 over 50, which is 0.78. Let's write this here. 0.78 LW. And that's the same as 0.78 A1, the original area. So if we reduce the length by increase the length by 20% and reduce W by 35%, that's the same as finding 78% of the original area, which is a reduction, because it says calculate the percentage reduction. The reduction is then 22%, because it's 100 minus 78 is 22%. I'll just write that at the side, guys. 100 minus 78 equals 22. Therefore, reduction is 22% or 22% here. Okay, that's question 13. Question 14. A, B, and C are points on the center of a circle. The radius is 8.5. Work out the perimeter of the shaded sector. Give your answer to 3 significant figures. Okay, guys, this is 132. Okay, if that is 132, if you recall, guys, angles at the circumference are half the angles at the center. So that means this angle here has to be double this. So this angle is 264 degrees. Okay, this angle is 264 degrees because it's double this angle at the center. This is a circle theorem, is twice the angle at the circumference. Okay, so this is 264 degrees, and then the length of the arc, so I'm going to call this L for length of an arc. This is from A all the way to C in this direction. So I'll actually just clarify that it's this. Oops, it is this all the way to here. So this is L. So to find L, I do 2 pi r, which is the circumference, 2 times pi times 8.5, that's the circumference of the circle, and I multiply it by 264 over 360. I do that because that's the fraction of the circle that I want. Okay, so it's 2 times pi, which is this, 2 times pi times 8.5 times 264 over 360. So it's 117 over 15 pi, but let's just write it as 39.165. 39.165. Now I'm not done, guys, because the perimeter is equal to L plus 8.5 plus 8.5, because remember, the perimeter is this plus this plus this. The perimeter is the length of the outside of the shape. So it's my L plus 8.5 plus 8.5. So it's L plus 2 times 8.5, if you like, and that is equal to 8.5 times 2 is 17. This plus 17, let's just do it, guys, on the calculator, plus 17 is 56.165. 56.165, and then we go 3 significant figures, so that's 56.2. Okay, 56.2. Question 15. Here are the numbers of aces that Rutger served in each of 11 tennis matches. Find the interquartile range of the numbers of aces. Show you're working clearly. Okay, so guys, this I think is quite straightforward, I hope. The interquartile range is Q3 minus Q1. Now Q3, let's find it. So there's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So the median has to be here, which means there's 5 to the left and 5 to the right. So this is the median, or Q2, which means the upper quartile is this guy. This is Q3, and the lower quartile is here, because he's in the middle of these 5 and he's in the middle of these 5. So Q3 is equal to 11 and Q1 is equal to 2. So it's 11 minus 2, which is equal to 9. Okay, Kim also plays in 11 tennis matches. This is someone else. For Kim, the median is 11 and the interquartile range is 5. State, giving a reason, whether Rutger or Kim served more aces on average. So on average, Kim served more because Kim served more because her median served more because 11 is greater than 8. There you go, because her median is bigger than Rutger's median. Let's just say as Rutger's median was 8. Now I've already said it here, but just to be clear. And state, giving a reason, whether Rutger or Kim was more consistent with the number of aces served. So consistency, guys, they're testing the interquartile range here. So who had a lower interquartile range? Kim had a lower interquartile range, so Kim was more consistent. So Kim, as her interquartile range is less than Rutger's. 5 is less than 9. Okay, question 16. Vectors. Here are two vectors. Write AC as a column vector. Okay, guys, it's nice, I think, to actually draw these out, right? So if we have, let's say, this is, okay, well, actually, I'll do it this way. BA. So BA is minus 5. Let's say B to A is minus 5, 4. Something like this. This is B, and this is A. And BC is 9, 1. So BC goes, let's just draw it like this, 9 across and 1 up. So this is BC. And let's just put the point there, that is C. So that is B to A, and this is B to C. So if I want to get from, what are we trying to find? AC. So if I'm trying to get from A to C, like this, I'm going to walk from A to B, and then from B to C. So AC is equal to AB plus BC. Now be careful, guys, we don't have AB, we have BA. But if BA is minus 5, 4, AB is negative that. So, sorry, AB is going to be 5, negative 4. So it's 5, negative 4. Because we're going the opposite direction, we just put a negative in both of these. So negative 5, which is plus, minus, minus, plus. And negative 4 is just negative 4. So this plus and BC we have, it's just 9, 1, 9, 1. And then this is 5 plus 9 is 14. And minus 4 plus 1 is minus 3. So it's 14, negative 3. Okay, question 17. Table gives information about the time taken by each student to complete a homework task. On the grid, draw a histogram for this information. Okay, so guys, I'm going to make a new column. It is frequency density. Okay, so frequency density, guys, is, I'll just write a little formula up here. Frequency density is the frequency divided by the class width. Okay, so if you ever forget that, guys, just remember the frequency is the area, which means the frequency is the frequency density times the class width. So to get the frequency density, I just divide this by the class width. Now his class width is from 10 to 25, which is 15. His class width is 5. His class width is 20, 30 to 50 is 20, and his class width is 10. So I do 15 divided by 15 is 1, 18 divided by 5 is 3.6. Use your calculator, guys. 32 divided by 20 is 1.6, I think. Yeah, 1.6. And 4 divided by 10 is 0.4. Okay, so now I just go from 10 to 25, which is 10 to 25 goes from here to here, and I'm going to go up to 1. Like so. 25 to 30, I go to 3.6. 3.5 and 3.6. 30 to 50 is 20. Sorry, 30 to 50 is 1.6. So I go to 1.6. And 50 to 60 is 0.4, like this here. Okay, so that's the histogram, guys. You can shade it in if you want. Don't have to. Okay, that is the histogram. Then he says one of these students who took 50 minutes or less and more than 25 minutes to complete his homework is chosen at random. Find an estimate for the probability that this student took 45 minutes or less to complete the homework. Okay, so that's slightly tricky, guys. First, we need to do between 25 and 50. So let's write students from 25 to 50. And then I'll just put a line here, and I need to get the area here. So 25 to 50. Now that one, actually, guys, I can do it easily enough because I can just say it's 18 plus 32, which is 50. So there's 50 students that I'm choosing from. Okay, and then it says find an estimate for the probability that this student took 45 minutes or less. So how many students took 45 minutes or less? Now what I'm going to do is I'm going to get this area here. Now guys, I don't want to be drawing on my histogram, but just to show you what's happening, make sure you erase this. So this green area here is how many students took between 30 and 45. So I'm going to do from 30 to 45, and that is 15 times 1.6. 15 times 1.6, which is, let's use our calculator, 15 times 1.6, so that's 24. So there's 24 people in this green area, but I have to do from 25 to 45, because now I'm going to also include these people, and there are these people, there are 18, so I need to add on this 18. So there's 18 from this column plus the 24 from the green area, and this is 42. So out of all these people, this is a conditional probability, guys, and I realize this is a bit tricky. So out of all the people from here to here, so let us let me just draw it with this. So everyone from here to here, there's 50, and I got that by getting the area, or I just actually looked at the table. But all in there, there's 50 people, and then I need to add on to 50. So from 25 to 50 here. Okay, so there, all that orange area, there's 50, and then I said right, but less than 45, which is here, there's 42 people. So there's 42 here out of the 50. So that's my probability. It's 42 out of 50. Okay, there you go, guys. I have to color that in. Right. So the answer is 42 out of 50. And now definitely in the exam, guys, you erase all that. Right, question 18. A statue and a model of the statue are mathematically similar. Statue surface area this, model surface area that, volume of the model is this, work out the volume of the statue. Okay, so guys, this is a nice question from what I can tell, because I can just go straight to scale factor, area factor, volume factor. This is how I like to do these similar shapes questions. So which one do we have? Well, we have the area factor. Now we're going to be going from the model to the statue. So we're going to go model to the statue. So I want the scale factor is going to be bigger than 1. I'm going to go from model to the statue. So, and its area we have. So the area factor is 3,600 over 625. This is what I would multiply to get from the model to the statue for area. Now this is equal to, if we simplify it, I've done it here, 144 over 25. Now that's a nice number, guys, because to get the scale factor, I square root that. And the square root of 144 over 25, you might know, is 12 over 5. You can use your calculator, guys, but square root of 144 is 12, square root of 25 is 5. Okay, and then to get the volume factor, I cube the scale factor. So it's just this cubed. Now let us do that. Let us do 12 over 5. Make sure you put a bracket, guys, because you have to cube both. 12 over 5 cubed, which is 1728 over 125. 1728 over 125. Okay, so if the volume of the model is this, the volume of the statue is equal to volume of the model, 750, times 1728 over 125 times the volume factor. And that is just this times 750, which gives us 10368 centimeters cubed. 10368 centimeters cubed. Exactly. Okay. Question 19. Prove algebraically that for any three consecutive even numbers, the sum of the squares of the smallest even number and the largest even number is 8 more than twice the square of the middle even number. Okay, so that's a strange question, guys. So it says the sum of the squares, three consecutive even numbers. So for three consecutive even numbers, I'm going to let 2n plus 2, so that gives me an even number, add 2 to get the next even number, and add 4 to get the third one. So let these be three consecutive even numbers. Okay. Then it says the sum of the squares of the smallest even number and the largest even number. So let's do that first. 2n squared, that's the smallest one, plus 2n plus 4 squared equals 4n squared plus, be careful, very careful, guys, doing this. It is, well, let's do it the long way. It's 2n plus 4 times 2n plus 4, which is, that's just 4n squared, and this becomes 2n times 2n is 4n squared. 2n times 4 is 8n. 4 plus 2n is also 8n, so it's going to be plus 8n plus 8n plus 16. Simplify this. 4n squared plus 4n squared is 8n squared. 8n plus 8n is 16n. And 16 is obviously just 16. Okay, so that's the sum of the squares of the smallest and the biggest. And we have to say that this is 8 more than twice the square of the middle number. So 8 more than, so twice the square of the middle number. Okay, so twice the square of the middle number is 2 times 2n plus 2 squared. Because I'm going to square this and multiply by 2 because it's twice. So this is equal to 2 times, again guys, let's be careful here, it's 2n plus 2 times 2n plus 2, which is 2 times, let's multiply this out, 2n times 2n, or guys, I could just multiply the 2 first, let's do that first. 2 times 2n is 4n, 2 times 2 is 4, so it's this times this. This is equal to 4n times 2n is 8n squared. 4n times 2 is plus 8n. 4 times 2n is plus 8n. And 4 times 2 is plus 8. This is equal to 8n squared plus 16n plus 8. Now look, can you see anything similar? This and this look very similar, except this is 8 more than it. So, and that was what we had to prove. Prove that this is 8 more than this. So I can just finish it off by saying 8n squared plus 16n plus 16 is 8 more than 8n squared plus 16n plus 8. So then I can just say hence proven, or fancy way to write that is QED. Okay, question 20. A, B, and C are 3 sets. We have the number of elements in this is 5, the number of elements in this is 2. Okay, so that's a lot of information. Let's go step by step. So the number of elements in A intersection B intersection C, that is in the middle of everything, is 5. So there's 5 in there. Fine. Next one. The number of elements that are in A and B and not in C. So what's in A and in B and not in C? That's this one here. They're in A and B, but they're not in C. A intersection C is 5. So this is A intersection C is 5. We already have 5, so that means here has to be 0 because they need to add up to 5. The number of elements in A is 17. 2 plus 5 plus 0 plus what gives me 17 has to be 10. 10 plus 2 plus 5 is 17. Next one. The number of elements that are in A union B union C complement, which is not in all of these or outside of these, is 3. So this guy has to be 3. Okay. Not in A and in B. So it's not in A, but it's in B, and it's not in C. So it has to be here. This is not in A, and it's in B, and it's not in C. So it's in B, and it's not in these two. There you go. B intersection C is 7. So here's 5. That means this must be 2, because 5 plus 2 is 7. And finally, this is 14. So 5 plus 2 plus what gives me 14? That's 7. And that's it, guys. Is that the question finished? Okay, not a bad question. Question 21. This is y equals f of x. The point P has x coordinate minus 2. Use the graph to find an estimate for the gradient of the curve at P. Okay, so guys, this is this question where you draw a tangent to the curve. Okay, now it's not always simple to get right, guys, but let's try this. And we're going to continue it on down like that. So obviously you're going to do it with a ruler. and you want to get a ruler, and you want to draw the line. Now you can extend it as far as you want, but now we're just going to get the gradient. Okay, so to get the gradient, we're going to do rise over run. You can get the rise over run from anywhere on the line. I think it's probably easiest, in this case at least, to just go, right, this will be the rise, and this will be the run. Okay, the gradient is approximately equal to, because it's definitely, guys, an estimate, so it's approximately equal to, this rise is 2, 3, 3.2, 3.4, let's say 3.5, so it's about 3.5. And this distance here, guys, I know it says minus, so it hits right at -7, so fine, that's -7, but the distance is 7. It's a positive distance, so rise over run, and this line obviously has a positive gradient because it's going up, so it would be a big mistake to put -7 here, and this is equal to a half. 3.5 over 7 is a half, so the gradient at that point is approximately a half. Question 22. Solve the simultaneous equation. Show clear algebraic working. Okay, so first step, guys, is to take the linear one, the one without the squares, and write it as, or change the subject to either y or x. It's easier to change it to y in this question, guys, because you won't have any fractions. So I just basically subtract the 2x from that side. Okay, now what I'm going to do is, instead of y, if I see y here, I'm going to put this instead of it. So instead of 2y squared, I'm going to put 2 minus 3 minus 2x squared plus x squared, that's just this, equals negative 6x plus 42. Multiply this out. This is going to be minus 3 minus 2x times minus 3 minus 2x. Don't do anything silly, guys, like multiplying by 2 first. You gotta square it first. Think your bid mass or bob mass. Okay, x squared equals minus 6x plus 42. I'll still wait, guys. I won't multiply by 2 yet. I'm going to do minus 3 times minus 3 is 9. Minus 3 times minus 2 is plus 6x, sorry. This times this is plus 6x, and this times this is plus 4x squared. Plus x squared, this one, equals minus 6x plus 42. Okay, then multiply out the 2. Or no, actually, guys, we could... Well, let's just skip one step. I'm going to do 2 times 9 is 18. And then this is 6x plus 6x, which is 12x, times 2 is plus 24x. Make sure you understand that. Plus 2 times 4x squared is 8x squared, plus x squared equals minus 6x plus 42. Okay. 8x squared plus x squared is 9x squared. I'm going to get everything on the left, guys. I have 24x plus 6x is 30x. And then I have 18 minus 42, which is minus 24. And this equals 0. Divide everything by 3 to make life easier. 3x squared plus 10x minus 8 equals 0. And now I need to factorize this. So many ways to factorize a quadratic, guys. My preferred way now is to do a times c, which is 3 times minus 8 is minus 24. And then what are the factors of minus 24 to give me plus 10? Well, it's 12 minus 2, because 12 minus 2 equals 10. And then I go 3x squared plus 12x minus 2x minus 8 equals 0. Factorize the first two, 3x into x plus 4, and then take out the negative 2 here, and I get x plus 4, and then my factors are 3x minus 2, that's 3x minus 2 here, and x plus 4. It's a bit like taking out the common factor, x plus 4 equals 0. So guys, however you want to factorize that is fine, so long as you get this answer here. You can use your calculator to kind of work backwards as well. So that means 3x minus 2 equals 0, or x plus 4 equals 0. So my solution here is 3x equals 2, or x equals 2/3. And my solution here is x equals negative 4. Now, note guys, back to here. Y is minus 3 minus 2x. So, y is minus 3 minus 2x. Y is minus 3 minus 2x, which means for this x, y is equal to minus 3 minus 4 over 3, if you like. And this is minus 9 over 3 minus 4 over 3 is minus 13 over 3. Use your calculator, guys, if you didn't know what I did there. And here, y is equal to minus 3. Minus 2 times minus 4 is plus 8. So here, y is equal to 5. So my two solutions are x equals 2/3 when y is equal to minus 13 over 3, or x equals minus 4 when y is equal to 5. Okay, question 23. A, C, and B, D are chords of a circle. We're given all this information. This angle says work out the size of angle ADE. So that's this guy here, guys. Let's call this angle ADE theta. Give your answer correct to one decimal place. Okay, so guys, one thing to note, this is a 5-mark question and they've given us a lot of space, and it's question 23. It's not going to be easy. So it's a circle theorems question, but it's not a simple one where I can just, so I could actually put in this value here is 48 degrees because of angles in the same segment. And this angle here would also be theta. So that might help me at some point if I wanted, guys. But the only way I can think of to do this is to find x. And I think almost certainly that's what they want us to do. And then use this triangle and trigonometry in the triangle to find the value of theta. So actually, yeah, we could do, guys, the sine rule, because if we have this side, if I have x, I'll have this side, I'll have this side, I'll have this angle, I can just use the sine rule. So let's go with that. Now to find x, and guys, he says chords, so that's kind of a key word here. I can use the intersecting chords theorem, which means this intersecting chords theorem, guys, states that the orange times the green equals the pink times the blue. That's what the intersecting chord theorem is. This times this equals this times this. So I can go to x plus 12 times x is equal to x plus 5 times 5x minus 12. Sorry, that's x plus 12, not 2. X plus 12. Okay, so let's solve this first. So multiply out, this is x squared plus 12x equals x times 5x is 5x squared, x times 12 minus 12x plus 25x minus 60. And then this is 5x squared minus 1x squared is 5x squared minus 1x squared is 4x squared. I'll subtract the 12x over here, so that'll be 25x minus 12x, which is just 1x. And then the minus 60 is on its own, and I have 0 here on the right. And then this becomes, guys, if I've just done one of these in the previous question, I think I do a times c, which is 4 times minus 60, which is negative 240. Okay, and I need to find what factors of negative 240 give me 1. So I'm definitely looking for two numbers right beside each other. So let me just think of what are the factors of 240. Maybe 20, maybe 15. Guys, what is 240 divided by 15 is 16. Okay, right. So the factors are 16 and 15. So I do, this is 16 minus 15, which gives me 4x. If in doubt, guys, you can always just use the quadratic formula if you can't factorize it. So it's 4x plus 16x minus 15x minus 60 equals 0, 4x squared. Factorize the first two, so I have 4x into x plus 4 minus 15 into x plus 4, giving me factors of 4x minus 15 times x plus 4. Therefore, 4x minus 15 equals 0, 4x equals 15, and x is 15 over 4. Okay, x cannot be negative 4, so I can't use this solution because x has to be positive because it's the length, and one of the lengths is x. Okay, so now I have, and it's 15 over 4, guys. Let's write that as a decimal. This is 3.75. 3.75. Okay, now I have this triangle where this length is 3.75 plus 8, which is 8.75. And this length is 3.75 plus 12, which is 15.75. So my sine rule will be sine, I'll do it up here, guys, just so you can see it. Sine theta over 8.75 equals sine 48 over 15.75. Sine theta is therefore, multiply across, 8.75 sine 48 over 15.75, and theta is just going to be the inverse sine of all this. So theta, let's go over here. Theta is inverse sine fraction 8.75. Let's put the times just to be safe. 8.75 times sine 48, close bracket, over 15.75, close the bigger bracket, press enter, and I get something I did not want to get. So it's, okay, I'm in radians, guys. Big error. So make sure your angle is in degrees. I just changed this for someone recently. Just keep it in degrees. So setup, if you're ever in doubt, shift, setup, and then angle unit is number 2 in big degrees. Okay, so let's do this again. There, so it's 24.38, and so 24.38. He says give your answer to one decimal place, so that would be 24.4 degrees. Okay, so down here, 24.4. Okay, question 24. The diagram shows a solid cone and a solid sphere. we're given some information. Fine. It says, given that k times the volume of the cone equals the volume of the sphere, show that the total surface area of the cone can be written as this. Okay, so guys, we have volume of the cone is pi. Sorry, it's a third. This is in the formula sheet, guys. A third pi r squared h. The volume of the sphere is 4 over 3 pi r cubed, also in the formula sheet. Okay, now we're told that this times k is equal to this. So that means that, let's just write that here, guys. A third pi r squared h times k is equal to 4 over 3 pi r cubed. Okay, let me write that, sorry, pull that here. Okay, and then he says, show that the total surface area of the cone can be written in this form, right? Guys, this is 6-mark question, obviously very difficult. So the total surface area of a cone, is equal to the area of the circle, which is pi r squared, plus the curved surface area of the cone, which in the formula sheet also, guys, is pi r L. Okay, now we want to turn this into this. Now, this formula has, well, whatever they've come up with, this answer has a pi in it, it has an r in it, it has a k in it, and it has some a, which is some number. What it doesn't have is an L or a h. So we need to remove the L and the h. So this equation here, let's get the h in terms of the other stuff. So we have, well, a few things we can do nice and easily, guys, is multiply across by 3, divide across by pi, divide across by r squared, which would leave 1 r over here, and I'm left with hk is equal to 4 r, or h is equal to 4 r over k. Okay, so now I have h in terms of r and k. Great, so I can sub this into this formula, but there is no h in this formula, there's just an L. But nicely, I can figure out there's a relationship between r and L and h. If this is r and this is h and this is L, this is a right angle triangle. I can say L squared is equal to r squared plus h squared. And then I can write L squared as r squared plus h squared, which is this. So 4 r over k all squared. Okay, now guys, I'm going to move down here and I'm going to turn this into this using this, right? So obviously not an easy question, guys. L squared is r squared plus, now let's expand this out. This is 16 r squared over 16 r squared over k squared. I can then common denominator of k squared. This is r squared k squared plus 16 r squared. And this, so this is my L squared. And just before I square root it, guys, let's do one more thing. It's r squared. I'm going to factorize r squared, and I'm left with k squared plus 16. Now I like that because here I see a k squared plus a, and here I have a k squared plus 16, so maybe that'll be useful soon. All over k squared, which means L is the square root of all this. So let's get the square root of that. And the square root is, I can't do k plus 4 obviously, guys, because it's 2 terms, but I can get the square, I can square root r squared into r, and I can square root k squared into k, and then I'm left with square root of k squared plus 16. So just to be clear, what I did is the square root of r squared is r, the square root of k squared is k, so they come outside the square root, and then I'm left with k squared plus 16 within the square root. Okay, so this now goes in instead of L, like this. So the total surface area is pi r squared plus pi r L, and L is, let's put a bracket, r over k times the square root of k squared plus 16. And this is turning into this, guys. It's pi r squared plus pi r squared over k, just multiply this out, times the square root of k squared plus 16. Common denominator of k, so this is going to be k pi r squared. I have to multiply this by k if I'm going to have a common denominator, plus pi r squared times k squared plus 16 all over k. So this is just common denominator, and then I can take out the pi r squared, which I like because it's out here. Take out the pi r squared, and what's left is at the top here a k plus a square root of k squared plus 16 all over the k, which is what he wants. And a then, a is a constant to be found, so a is 16. Okay, obviously guys, very, very tricky question. Okay, question 25. ABCD is a trapezium with AB parallel to DC. ABC of these coordinates. Find the trapezium is one line of symmetry. The line of symmetry intersects CD at point E. Work out the coordinates of point E. Right. I have no idea what to do, so I'm going to start drawing things, right? Because he's actually given me the exact coordinates, guys, I think I'll actually draw a grid. So this guy's at -4, 6. So let's go -4, 6. This is A. B is at 2, 3. 2, 3. Obviously, guys, this doesn't have to be exact. That's B. And let's put in -4, 6. B is 2, 3. And D is -1, 8. Okay, guys, I've misunderstood this whole thing. -1 here, 8 there. Okay, this is D. -1, 8. I'll just erase this like so. Okay, the trapezium has one line of symmetry. So hang on, AB is parallel to DC. So we don't have C, but if AB is parallel to it, parallel to CD, C obviously has to be like here somewhere. And it has a line of symmetry, so let's say there. So this is C. I don't know the coordinates, but it's somewhere there because this is a trapezium and it's a trapezium with a line of symmetry. So the line of symmetry is going from the middle down through, okay, down through here. So obviously my drawing is not perfect, but you get the point. So there's one line of symmetry. The line of symmetry intersects CD at point E. So this here is point E. That is point E. Work out the coordinates of point E. Okay. The way to do it, guys, I believe, is, okay, how many points are we talking about? 6 marks. So yeah, I look at that to see how much working I'm dealing with, guys. But okay, this is what I'm thinking. We can get this point here because it's the midpoint of these two. And then I can get this gradient because I can get the gradient of AB. Hence I can get the equation of the green line. Then I can get the equation of DC, of the line that goes through D and C, because I have a point and I know the gradient will be the same as AB. And then I'll just find where the two lines intersect, and that would be E. So that's my plan. Okay, so first let's get the gradient of AB. So I'll call that MAB. So that's y2 minus y1, which is 3 minus 6 over 2 minus negative 4, which is negative 3 over 6, or a half. Okay, sorry, negative a half, which makes sense. That looks about negative a half according to my diagram. Okay, then let's get the perpendicular gradient. The perpendicular gradient, let's just call it perpendicular, is equal to 2, because it's the negative reciprocal. Flip that upside down, change the sign, and it's 2. Okay, so equation of the line of symmetry, let's call it, well, let's do it here, equation of line of symmetry. The equation of the line of symmetry. Okay, so that is going to be, well, actually, sorry, before I do that, let me just get rid of this. Before I do that, I need the midpoint. So midpoint, I'll just put A, B in brackets. The midpoint of AB is x2 plus x1, so that's minus 4 plus 2 over 2, comma 6 plus 3 over 2, which is minus 1, comma 9 over 2. That's the midpoint. So now I'll get the equation of the line of symmetry, and I'll get it from this gradient, y equals mx plus c. The gradient is 2, and again it does look a bit like it should be 2x plus c, and this point, so I'm going to sub in 9 over 2 for y, negative 1 for x, and I can get my c. C is equal to 9 over 2 plus 2, which is 9 over 2 plus 4 over 2, which is 13 over 2. Just make sure, guys, you know how to do that, or use your calculator. Okay, so the equation of the line of symmetry is y equals 2x plus 13 over 2. That also looks about right because it's just above A, which is 6. Okay, this is about 6.5. So that's the equation of the line of symmetry. Now, the equation of DC is, let me write it here, guys. Equation of DC. Okay, equation of, let's say, line through DC. So same thing, y equals mx plus c. My m is minus a half because this line DC is parallel to AB. It says that at the start. And this guy's AB gradient is minus a half. So DC's gradient is minus a half. And it goes through the point D, which is minus 1/8. So here I'm going to put minus 1, 8 or 8 here, and minus 1 here, minus a half times minus 1 plus c. C equals 8 plus 1 over 2. Sorry, 8 minus 1 over 2, because this is, okay, let's just, guys, before I make a mistake, this is 8 equals 1 over 2 plus c. So c is 8 minus 1 over 2, which is 16 over 2, minus 1 over 2, which is 15 over 2. So the equation of the line through DC is y equals mx minus a half x plus c plus 15 over 2. Okay, so now I have the equation of the line of symmetry, I have the equation of DC. To find E, I just need to find the intersection. So the intersection of these two lines. So let's write it here as intersection. Where does this equal this? So because they're both y, I can just equate them. So it's 2x plus 13 over 2 equals minus a half x plus 15 over 2. 2x plus a half x equals 15 over 2 minus 13 over 2, which is actually just 1. 2x plus a half x is 4 over 2x plus 1 over 2x is 5 over 2x equals 1. X is equal to 2 over 5, which is 0.4. And then once I have this, I can sub it into either of the two equations to get y. Y is equal to 1 second, guys, I have a pen issue. Y is equal to 2 times x, so 2 times 0.4, 2 times x plus 13 over 2. And that, guys, is, you can use your calculator obviously, but it's 0.8 plus 6.5, which is 7.3. So the coordinates are 0.4, 7.3. Does that make sense? Yeah, it makes sense that it would be near 0 and quite high. So 0.4, 7.3, 0.4, 7.3. Okay, last question, I believe. And actually, not too bad. Well, I don't mind these questions. So write as a single fraction in its simplest form. Okay. We're going to factorize, guys. We're going to factorize this, we're going to factorize this, we're going to factorize this, and then we'll see what to do with that in a second. But let's factorize this. So 4x squared minus 17x minus 15. This is equal to factors of this, right? Let's do it, guys. A times c. A times c is minus 60. Factors of minus 60 to give me 17. That's going to be our negative 17, negative 20 times plus 3. So I write this as 4x squared minus 20x plus 3x minus 15. Factorize the first two, 4x into x minus 5. Plus 3, factorize the second two into x minus 5. And now we have 4x plus 3 into x minus 5. Okay, that's the first bit. Second one, 2x squared minus 7x plus 3. Same thing over here. A times c equals 6. Factors of 6 to give me negative 7, negative 6, and negative 1. So this is going to be 2x squared minus 6x minus 1x plus 3. Factorize the first two, 2x into x minus 3, and then do minus 1 into x minus 3. It has to be minus 3 because minus times minus gives me plus. They're the same, which I wanted, so I'm left with 2x minus 1 times x minus 3. Okay, that is this factorized and this factorized. Now x squared minus 25 can be factorized as a difference of two squares into x plus 5 times x minus 5. That's the difference of two squares. I can go straight to that. Okay, now I have everything factorized. Let's write this out. So this numerator becomes 4x plus 3. 4x plus 3 times x minus 5. And the denominator is 2x minus 1 times 2x minus 1 times x minus 3, that's this factorized, all over x plus 5 times x minus 5. Now there is this annoying thing at the end, so let's just add it at the end. It's 29 minus 4x. Okay, now at this point I'm going to move down. So some things cancel. So we have the 2x minus 1 cancels with the 2x minus 1, and the x minus 5 cancels with the x minus 5. So here we have 4x plus 3 multiplied by, because we're multiplying across here, by x minus 3. And at the bottom I have x plus 5. So this whole part here equals this. And we're now going to add this. But guys, I may as well at this point make a common denominator, because I'm going to add two fractions. I need a common denominator. So the common denominator will be x plus 5. And if I multiply this by, like this has a denominator of 1. So if I multiply this 1 by x plus 5, I have to multiply this numerator by x plus 5. Okay, so now the denominator is common, so I can just join them together, but I'm going to multiply out the brackets. So 4x times x is 4x squared minus 12x plus 3x minus 9 plus, and I'm just going to add this, 29 times x is 29x, 29 times 5 is 145, use your calculator, minus 4x squared, and minus 20x. That is the numerator, and that is all over x plus 5. Now, again, a few things are going to cancel. 4x squared cancels with 4x squared. We have minus 12x minus 3x. Let me just get this straight, guys. This is minus 12x plus 3x is minus 9x. Minus 9x plus 29x is 20x, and the 20x minus 20x is gone. So these minus 12 plus 3 plus 29 minus 20 is 0. So we're just left with minus 9 plus 145, which is actually 136, over x plus 5, and that's it. 136 over x plus 5. Okay, that's it, guys. That is the paper.